I looked at this file you sent me.
Yeah.
Unit 5 integration. This is pretty tough stuff. Took me a while to work my way through all 20 of them. Have you started it at all yourself?
Yeah, I have some of it done. I was actually working on it just now.
Okay, tell me where you want to begin.
We should begin. Well, the two that I think I've looked through the whole thing. I haven't done them all, but the two that look like they would be giving me the hardest trouble,
Or 19.
which I want to work on. 1920, yeah.
Yeah. Okay. Let's not begin there.
But besides that, there's not the slope field stuff. The slope field stuff I know well, but the rest of it I think
Okay.
quick pass will be fine.
So we should go through each one?
Yeah, I guess starting at the beginning is always good.
Yeah, okay. So this one here, let me position my thing a little bit better here. The multiple choice doesn't really help on very many of these. You still have to be able to know how to do it.
Yeah.
So how do I do this?
This first one. First, if f of x dx equals a to the 2b, then a f of x plus 5 equals dx
Equals what? Yeah.
equals what? Then, so, would we...
Let's start with what's on the right.
Yes.
What else is that equal to?
The integration of f of x a to b plus the integration of f of 5.
And this is equal to what?
A plus 2b.
And this is equal to what?
5.
What's the integral of 5?
5 dx.
5x. 5x.
Yeah, 5x.
5x evaluated from a to b, which is going to be 5b minus 5a.
And then when we add those together, we get 7b and negative 4, which is c.
C. Okay.
The average value of cosine
Average
x.
value of cosine x on the interval. So first of all, what is average value equal to? What's the general formula?
As an average value, it integrated with those as the two.
Almost, not quite. The average value is 1 over b minus a. So the average value is going to be 1/8.
1/8 of the interval.
Of this integral. So let's take this integral. What's the integral of cosine x?
Sine x.
So
That will be
sine x evaluated from -3. So what does that give us?
Sine. That's evaluated at negative 3.
Start at the top. It's the top
Sine of
minus,
5.
right, minus the bottom.
So sine of 5 is 2, right?
Hold on. Think about this for a moment. Sine of -3 is the same as the minus sine of 3. So this becomes sine of 5 plus sine of 3 over 8. E.
Oh, so that's just a matter of knowing.
Yes. Let's just double check that. Yeah. When I first looked at this problem, I didn't even see this, that it was the sine of 5 plus the sine of minus 3. And you do need to know that the sine of minus x is equal to minus the sine of x. In other words, that's an odd function. Has symmetry about the origin. So whenever you have the negative angle, you can treat it like this. Cosine, incidentally, is even. Cosine of minus x is equal to cosine of x. Okay?
Okay.
All right. Now we have this problem. This may look familiar because I'm pretty sure we had exactly the same problem.
Line and so.
And I had difficulty with it the first time we had it. And you told me what the answer was, and I could not reconcile. And then about 4 days after our session, I'm sitting there watching TV on the couch, and it occurs to me why that is the correct answer. So the odd thing is that when I looked at this problem again this morning, I could not reconcile it. I spent about a half an hour trying to get this thing to work, and I could not figure it out, and I could not remember what I had discovered before. And I put it aside and worked my way through to the end and saw that you had answers at the end, and so I went and looked up the answer, and I realized that it was D, but why? And I finally figured it out. First of all, if we graph this function, D that is, not this. In other words, we're going to basically try to back solve this. That's what I did the first time through this morning, and I couldn't get any of them to work. For some reason, I didn't do D properly. Let's look at D. D is the square root function shifted 1 to the left, correct?
Yes.
So that's f of x equals x square root of x plus 1. And that's minus 1 there. And that's plus 1 there. And expression D would be the area under the curve from 0 to 1, right?
Yes.
Okay. How is that equal to this? Well, let's use rectangular approximation, which means I'm going to divide this thing up into 25 intervals. And it's not super easy to see other than the fact that all of our other answers, well, we got all these 25s in here. Just trust me, when we do this, you're going to see why it works. What is this coordinate right there, the very first one?
125.
So if I go back up into this sum, if I sum up all 25 of these rectangles, I'm going to have the sum. What's the width of each rectangle?
The width of each rectangle is 125th.
What is the height of the first rectangle? F of 125th. Right?
Yeah.
In other words, that's what the realization you have to make on this. That is f of 125th. I'm assuming I'm using a right rectangular method. That's the area of that first rectangle. Plus the height of the second rectangle is f of 2/25. Dot, dot, dot. Well, what is f of 1/25 equal to? If D is the right answer, then f of 1/25 is the square root of 1/25 plus 1. F of 2/25 is the square root of 2/25 plus 1, which is what this series is doing.
Yeah.
Multiplied by 1/25 because that's the width of each rectangle. In other words, what we have here is a right-hand Riemann sum. The width of each rectangle times the right coordinate is this expression right there. That also happens to be the area under that curve from 0 to 1. Now, how you go backwards on this, I'm not sure. I would have a hard time if this was not multiple choice. I had a hard time with it, and it was multiple choice. But once I saw the answer for sure was this, I was able to figure out how that is, why that is true. Because I kept wanting to say E. I kept wanting to say E when you and I looked at it before. But if it was E, I would be dividing it up into, the width would be 1. So I would never be multiplying it by 1/25. So E didn't make sense. It didn't fit my model. But I couldn't match D to that until I looked and saw for sure that D was the answer. So this is a tough one. This may be the toughest question, the toughest multiple choice question on this exam. Although there's a lot of them, a lot of tough ones. Let's look at this.
Graph of f is shown in the figure if f of x dx.
Yeah. Hold on.
That is
okay. So first of all, they don't do a very good job of defining what they're talking about here. F of x is this integral of little f of x dx. That's what they forgot to say. And that's important. It took me a while to figure this one out because I couldn't quite figure out what capital F of x meant. They give us the capital F of x is, well, I guess one way to figure it out is the fundamental theorem of calculus has two parts to it. The first part says that if f of x is equal to that integral, then f prime of x is equal to f of x, which is what this statement says.
Yeah.
So that tells us what f has to be. F has to be the integral of little f of x from 1 to 3, because they're saying that f of capital F prime of x is equal to this, and if I took the first, if f of x was equal to this and I took its first derivative, I would get f of x. So we're looking at the right thing. All right, now they're saying that this integral, the area under this curve between 1 and 3 is 2.3. Well, there's 1, there's a half, there's about 3/4, so I can see that the area under that curve is indeed 2.3. That's what that statement means.
Yeah.
So capital F of 3 would mean capital F of 3 would be the integral from 0 to 3 of f of x dx. In other words, f of 3 is the same as the area under the curve from 0 to 3.
Yes.
F of 0
just the area under the curve at that point 0.
Hold on, let's see. Let me go back a step here. I lost my train here. If I take f of 3 minus f of 0, I get the entire area under that curve.
Yeah.
That's what they're asking for. Well, what do I know? I know what f of 3 minus f of 1 is. That's that thing right there. If I evaluate that integral, I get capital F of 3 minus capital F evaluated at 1, right? Yeah. They're telling me that's equal to 2.3. Well, if I look at that curve, and they say if this area between 1 and 3 is equal to 2.3, well, f of 3 minus f of 0 must be the area of the curve from 0 to 3. How much more is that?
Looks like about 2 more.
D has to be the right answer. 4.3. Very esoteric problems here, which nobody likes, I'm sure. I'm sure you don't like them any more than I like them. I'd much rather they give you a bunch of functions to integrate and go from there. But if you can get through these, you really do understand it quite well. So here we have a table of values representing a continuous function. If 4 equal subintervals of 0 to 2 are used, which of the following is the trapezoidal approximation of that area? Well, let's go through the trapezoidal rule. Not so much the rule. Let me graph this. So we go from 3 to 13 on the f of x axis. And on the x-axis we go from 0 to 2. And they said do 4 intervals. And the function is 3, 3, 5, 8, and 13. They said it was continuous, so I'm going to connect the dots. And we're going to use the trapezoidal method. So let's find the area of each of these rectangles, add them all up.
So the trapezoidal rule is the
Let's go through it rather than relying on the rule.
Okay.
Let's go through it manually. Only because we only have 4 of them. So what is the area of 1?
The area of 1 we 3 to 3, so that's just... So that's 3 times 0.5, that'd just be 1.5.
Okay. It's the area of 2.
The area of 2, we have...
This point right here is 5. And this point right here is 8.
And for a trapezoid, we have it's 1/2 the height, or 1/2 times height times base 1 plus base 2, right?
Yes.
So
So
then we have
base 1 is what?
base 1 is 3 and base 2 is 5, right?
Yeah. So the average, I tend to think of the area of a trapezoid as being your average base times the height. Instead of like a rectangle is your base times the height. Well, this is the average base, and you get the average base by taking base 1 plus base 2 and dividing by 2.
We have a base of 4.
Right. Times 1/2, that area is 2. Whoops, excuse me. I meant to do it this way here. Ah. So area 2 equals 2.
And then
Area 3 equals...
We have 5 plus 18 is 13. 13 divided by 2, 6.5 times 1/2. We get 5 times 3.25.
Yep.
The area.
Mm-hmm. And finally, area 4.
We have 13 plus 8 is the bases divided by 2, 10.5 times the 0.5. We have 5.25.
Yep. Okay, so now let's add those all together. We got 3.5, 7 3/4, 12 and change. Hold on. 7 and... Did I do that right? 3.5 plus 3 1/4 is 6 3/4 plus 5 1/4, 12. Okay?
Okay.
Now, notice when we did that, we used this base twice. We used this base in 2 of the calculations. We used this base in 2 of the calculations, but we only used this base once, and we only used this base once. That's why the formula for the trapezoidal rule has 1 of those plus 2 of those, 2 of those, 2 of those, and 1 of the last. And when you use the formula, that's why it is that way. But it's definitely worth doing it manually when there's so few of them that we could do it manually, I think. Which of these are antiderivatives? Hold on a second. Now, how are we going to do this problem?
Which of the following are antiderivatives? Wouldn't it be easier just to take the derivative of each of the answers and see what you get?
Yes. Obviously, probably more than one of them is, which means if we tried to take the antiderivative of that, we would have multiple answers. There are more functions than just one, quite possibly at least. And we don't yet have the tools to know how to take that antiderivative. We don't know how to take the integral of sine x cosine x. We haven't learned how to do that yet. So what we do know how to do is differentiate any function you can give. So if f of x were equal to sine squared of x over 2, find f prime of x.
Then 2 do that one works.
Good. How about cosine squared?
Cosine squared of x over 2.
What is it? Let's go through it.
Go through it. Pull out the over 2, right? So we take it as like 1/2 times cosine of 2x.
Now this is cosine squared of x. We're looking
Sorry, yeah.
at
Cosine
this
squared
one
x.
here.
I said that wrong.
Well, the way to integrate this is with u substitution.
Yeah.
U is going to be cosine of x, so that we end up with u squared over 2. Okay? So the inside is that. We don't actually have to use u substitution. We just have to know what the inside is. We're going to apply the chain rule. So if u is cosine x and I'm going to differentiate the outside, then it's u squared, so it would be 2u, subtract 1 from the exponent, still divide by 2, but now we have to apply the chain rule and multiply it by the derivative of cosine,
which is negative sine.
Which is negative sine, which means
we get negative sine.
Right, so that doesn't work.
Which doesn't work.
3.
The next one, negative cosine of 2x over 4.
Let's start taking the derivative of
it. Begin with the negative cosine turning into sine. Well, actually, we should do the inside first.
No, we know the inside is
2x, which then derivates into 2. And then 2. So then,
so far so good.
Yeah, and then I guess cancel the 2 and the 4, so we have sine of 2x over 1/2.
Over 2.
Oh yeah, because I think that looks clean.
Now use your double angle formula.
Double angle formula?
Yeah, what's the sine of 2x? It's equal, in trig, it's equal to the 2 sine of x cosine of x. Bingo.
And then we have that over 2, and then the 2's cancel again.
Yeah. So
1 and 3. And
1 and 3. And notice that if I did know how to integrate that, it's doubtful I would have gotten that as an answer. I probably would have gotten 1. And that is the way to integrate it is once you learn how to integrate trig function products, you would get 1 as an answer. I don't think I'd ever get 3, but these are trig identities. This number 3 is equal to that. That would be an easy trig identity to verify.
One of the answers is 1 and 3.
Yeah, D. This one. Man, somebody must spend all night up thinking of these problems. Is 1 true?
If f and g are continuous functions, and if f is greater than or equal to 0 for all real numbers x, which of the following must be true? Is 1 f of x true as equivalent? Is 1 true?
No, it is not.
No.
No.
Yeah.
And for the same reason that the integral of sine cosine is not, in other words, the problem we just had is the product of that times that. That's definitely not equal to the sine x times the cosine x.
Yeah, you can't break
Products are what makes integration tough. Just the fact that you cannot separate the product of two functions. If we could do this, integration would be easy. It really would be. All of the difficulties in integration are caused by the fact that that is not true. How about number 2?
2 is true. You can break the addition of that.
It is. And that's another key about what we like about integration. If we can separate it into addition, then it works quite nicely. About number 3.
Number 3, f square root of f of dx. No, that's not true. No, I don't believe it to be.
That's pretty funny. That's almost the exact words that went through my head. I'm pretty sure that's not true, but gosh, is it possible that it is? How can we test it?
Test it.
Let's make up a function. I made up x to the 4th.
Yeah.
So now, what is the square root of x to the 4th dx from a to b? Well, that's pretty easy. That's equal to square root of x squared from a to b, which is x cubed over 3, or b cubed over 3 minus a cubed over 3. So that's what the left side is equal to. Now let's take the right side and see if we get the same thing. Let's take the square root of the integral of x to the 4th. Well, the integral of x to the 4th is x to the 5th over 5. So that's going to be b to the 5th over 5 minus a to the 5th over 5. Now when I take the square root of that, it is certainly not equal to b to the 3rd over 3 minus a to the 3rd over 3.
That one just...
It didn't look right, but I couldn't be sure it wasn't correct. I thought, maybe that's something I just didn't know about integrals. So it's
doesn't work.
2 only for 7.
That's b?
Yeah.
Yeah, I've done all these.
Hi. Come here. Okay, this is a particularly easy integral to do. Why?
Yeah. Because, well, it doesn't have the nasty stuff to deal with.
Well, it's because the derivative of the inside, if we had to pen something, if we had to use u substitution, u is going to be x cubed plus 1. And the derivative of that happens to be 3x squared.
Then you can just u substitute.
Exactly. So when I use u substitution, du dx equals 3x squared, making du equal 3x squared dx. Well, there's 3x squared dx right there. I'm just going to substitute du for it. And then in the bottom, I got the square root of u. Now I can do this integral pretty easily. That's u to the minus 1/2, so that's, I add 1 to the exponent, divide by the new exponent. So there's my answer, but now I got to go back and resubstitute what I had for u. That's what I'm looking for. A.
Yeah.
Always look for that first step that is the derivative of the inside in the numerator. And if it is, you're going to be able to do it with U substitution. How are we going to do this one?
This one.
9.
Evaluate the integral x squared plus 1 squared dx. Would this be done simply... I want to say you substitute the inside and then do it.
Well, notice that the derivative of the inside would be 2x. In other words, that would work great if we had a 2x like this.
But we
because
don't.
then that 2x would get taken care of. So we can't use U substitution here. What can we do, though?
We can... Could we break that up, just actually multiply the two polynomials together and then break it into multiple integrals?
Exactly. That's what it is when it's squared. And those are easy to do.
Yeah, we do those also.
Must be C. Because I knew it had an x to the 5th in it. Okay. Yeah, never overlook the obvious, which on that case was kind of... In other words, sometimes we can get so involved in trying to solve by U substitution or parts. Have you had integration by parts yet?
Integration by parts. I don't think so.
Okay. That's
I've
coming.
heard of it, but I don't think I've been taught it.
That's coming next. Okay, at least I think it is. If y equals f of x and f double prime of x equals x squared and f prime of 0 equals 7 and f of 0 equals minus 8, how do we find the original function? In other words, how do we solve for f of x?
How do we solve for f of x? We have the second derivative, the first derivative, and we have the second derivative, we have the first derivative at 0, and the second derivative at 0.
So what is f prime of x?
F prime of x, we just integrate the x squared, right?
Mm-hmm.
So we get x cubed over 3
Plus c.
plus c.
Okay. Now we can use this information that f prime of 0 equals 7. Well, I know what f prime of x is, so let's make f prime of 0 equals 0 cubed over 3, so it's equal to c. That's equal to 7. c is equal to 7. So now f prime of x equals x cubed over 3 plus 7. What's f of x equal?
X to the 4th over 12 plus 7x plus c.
And now we are told that that is f of 0 equals minus 8. So f of 0, I'm going to plug in 0 for x. That's going to be equal to c. You see that step? I don't mean to skip over that step.
Yeah.
Okay. And they're saying that's minus 8, so now we have our function. F of x equals x to the 4th over 12 plus 7x minus 8. In other words, what we basically have done here is solve two differential equations with a starting condition on each.
Well, that's not too hard.
No. Always, in other words, it's the same exact problem as saying this. dy dx equals x squared, and f of 0 equals 2? Well, if dy dx equals x squared, then y equals x cubed over 3 plus c, and that's f of x. And if f of 0, c must be 2. So whenever you are solving a differential equation with an initial condition, always know that the solution here gives you a c, and you're going to solve c by that initial condition. And this problem just did it twice, is all. In other words, and that's pretty common because that's what happens when you have velocity, acceleration, and position.
Yeah.
That's the velocity function, that's the acceleration function, f of x is the position function. They gave us the acceleration function and what the acceleration at time 0 was. So we could solve for the first c. Okay. What is the derivative of an integral equal?
The derivative of an integral.
This is basically the first part of the fundamental theorem of calculus. The fundamental theorem.
Integral?
Yeah, it's just this function. But only if it goes from a number to a variable like that.
Yeah.
Then that's cosine of 2 pi x is the answer. D. Not, you'll notice, times the derivative of the inside, or the divided by, 11. Is 11D? Yeah. Yeah, if, the only way this could be a little bit harder is if it said the integral from 0 to x squared. If I take the derivative over dx of this integral, then it's substituting x squared in for u, but then you also have to multiply it by the derivative of u. So that would be the answer if the integral was from 0 to x squared. Incidentally, if it was from 5 to x squared, same answer. Or in this case, from 5 to x, same answer. As long as it goes from a constant to the variable, then the derivative of the integral is just this substituting x for this variable. Oh, this one, I like this one.
Yeah.
They got some good problems on this.
Yeah, they do.
I'm looking for a basic test to work with my cousin who wants to learn calculus, and boy, I'm going to start here. We've already been through calculus once, but I wanted to go through it a little deeper the next time. This is a good one to do. First of all, do I know what the antiderivative of that is?
The antiderivative of that.
Can you integrate that function?
Yeah.
How?
Wouldn't you have to? I would assume I would do it by writing that as 2x minus 5, or 25 minus x squared to the 1/2, and then multiplying the two together and then breaking it apart.
If you try to use the power rule, you won't get anywhere.
Yeah.
3/2 multiplied by 2/3, but there's a derivative of the inside that is nowhere to be found. If this whole thing was multiplied by 2x, then I could do it this way.
Yes.
But once again, here's a function that I don't know how to integrate this. Certainly at this level of calculus, you haven't learned yet how to integrate this. However, do you recognize that function? That's a good function to recognize. the equation of a circle?
Oh, yeah.
Here's the equation of a circle. If you solve for y, you get,
Yeah. That's the radius in the x.
that is how much of a circle?
That is the whole circle, right?
No, the whole circle would be plus or minus this. In other words, when I solve for y, I forgot to put the plus or minus, incidentally. The plus side is this side, the minus side is this side. It's not even just the top half. It's only from 0 to 5. In other words, this is the equation of a circle at the origin with radius 5. It's the equation of this circle right here, where that point is 5. So when they integrate this function, first of all, the function is only the top half of the circle, and when we integrate it from 0 to 5, we're only getting a quarter of the circle. So it is a quarter of the area of this circle of radius 5, which is 25 pi, divided by 4. Answer E. They are tricky. I mean, I'm a math tutor, so I maybe am going to recognize. I didn't recognize that at first as the radius or as the equation of a circle. It took me a while realizing that we had no way to integrate it otherwise. All right, this problem I did not like.
Mean value.
Let's talk about the mean value theorem. If f of x is equal to x squared, a curved line, the mean value theorem says that whatever the average rate of change between f of a and f of b is, there is going to be a point C between A and B whose derivative will equal that rate of change.
Yeah.
What is the rate of change from A to B?
From A to B we have
Rise over run. So what's the rise?
the rise is x is 5, that's why 4 over
F of B minus F of A,
so 2.
all over B minus A. Well, what I'm trying to get at is if I said what is the average rate of change between that point on the curve and this point on the curve, you would find the slope of that line, right?
Yeah.
Which is, this point up here is f of b, this point down here is f of a, the run is b minus a. So this expression right there gives me the average rate of change between a and b. And what the mean value theorem says is that somewhere on this curve there is going to be a point, there has to be a point whose derivative is that same slope. In other words, that is going to equal some derivative of the function evaluated at C. So in this particular problem, I would take the derivative of this function, I would get 2x, and I would set 2x equal to f prime of C and solve for C. But in our problem, they give us a linear function, not a second degree function. They say f of x is equal to 2x. So that plot's entirely different. That's just a straight line. So I know what the average rate of change on that straight line is from 1 to 2. It's 2, right?
Yes.
No, excuse me, it's 3. No, it's 2. It's f of 2, f of 2, which is 4, minus f of 1, which is 2, so we get 2. So I know that the average rate of change, this right here, is equal to 2. And I also know by the mean value theorem that that's equal to some f prime of c. Well, if I take f prime of x, that's equal to 2. Well, f prime of c is equal to 2. So any of these answers that are in the interval work. 3/2 works, 4/3 works, 2 works. Notice that C, any point in between 1 and 2, if I pick that point right there, has the same slope as the average slope. If I pick this point right here, it's got a slope of 2. Here's a slope of 2. Here's a slope of 2. This is a horrible problem to illustrate the mean value theorem on, because the average rate of change between this interval is exactly 2, and every single point between 1 and 2 has that. So any answer between 1 and 2 works. I'm going to check and see what the answer here was. 14C. So they said 3/2. Well, that's fine. That works. Halfway in between is fine. That also has a slope of 2. But so does 4/3. If I go to 4/3, which is right here, that is also a point C, who f prime of C equals the average change.
Okay, what?
So all I'm saying is that point D also works as a value of C, and 2 also works as a value of C. Let's look at this. They didn't give a different letter. They went DD. That's a bit of a, I guess that's why you can't choose that. See, I wonder if they did that on purpose. You think?
I don't know.
No, but it kind of makes sense, because any of these 3 answers is correct, but you can't choose this one without choosing this one. And so this would be the only one that's uniquely correct? I don't know. That's kind of a funny thing.
I guess that would force you to read the question.
I suppose. I don't know. I hate the question because they used a linear function. It doesn't illustrate the mean value theorem very well when you have a linear function. All right, this is another great question here. I tell you what, these questions took me about an hour and a half to do this morning. What is this, 15? I know you wanted to look at the harder ones, but these are plenty hard.
Yeah, they are.
Which is the best approximation for that? What should we do to try to answer this? What does this mean? The integral from 0 to 2 of this function dx.
That's just... Isn't that the, like the Riemann sum of it?
It's the area, it's the area under the curve. The area under the curve, and that's hugely important to know. That's what it means. There's the curve. F of x equals x squared plus 1. They want the area from 0 to 2. So that's the area we're looking for.
Yeah.
If we look at their answer, first of all, they say, what's the best approximation for it? Well, clearly they're going to use either a rectangular method, a trapezoidal method, some sort of a method, adding up slivers of this thing underneath. So let's try a rectangular method. How many intervals do I want to break it up into?
How many
Intervals.
Yeah.
Oops, hold on. I'm going to give myself a little more room here.
I don't know how many intervals I'd want to break that into.
Well,
I mean,
only if you look at the answers. Well, if you look at the answers, you can tell how many they've broken it into.
Looks like 8.
Yeah, they all go from 1 to 8. This sigma means we're going to add up this series, and the first interval if you divide up from 0 to 2 into 8 intervals, what is the area of the first interval? 1.
The area of the first.
Area of 1 is?
We have a width of 1/4 and a height of f of x evaluated at 1/4.
F of 1/4. If we're going to use a right-hand method. If we were using left-hand rectangles, this would be f of 0.
Yeah.
But we'll use a right-hand method and see where we get. Okay, that's area. The total area is going to be the sum of that plus 1/4 times f of 2/4, and so forth and so on. Right? You with me?
Yeah.
Okay, so that, the total area we're looking at, we're going to take the 1/4 out like they did. Notice they have 2/8 out in front.
Yeah.
Times the series. What is f of 1/4?
F of 1/4. 1/4 squared plus 1.
Okay, so that's 1/16 plus 1, correct?
Yeah.
That's the first interval.
Which
What's the next one?
the next one is 2/16 plus 1.
Be 4/16. It'd be 1/4.
Oh, 4/16? Oh, yeah, because it's 2/4.
So it's 1/4 plus 1.
Got it.
So now, if we look at all of their choices, they all have a plus 1 added. They're all squared. So I need to find one of these answers whose first term is 1/4. Excuse me. Hold on a second. Hold on a second. F of 1/4 would be just this squared. Hold on. I had this all worked out. Let me think about this for a second. Yeah, here's what I want. Let me rewrite this for a moment. F of 1/4 is 1/4 squared plus 1, right? F of 2/4 is 2/4 squared plus 1.
Yeah.
The next term is going to be f of 3/4, or rather 3/4 squared plus 1. So do we have any term here that is counting up? They've got the squared and they've got the plus 1. So we need everything in the parentheses to be equal to 1/4 when I is 1. So when I equals 1, all of this needs to be 1/4. Well, up here, when I is 1, it's equal to 0.
0.
Here, when I is 1, it's 1/8. Here, when I is 1, it's 1/8. And here, when I is 1, it's 1/16. None of these give us a first term of 1/4 squared. In other words, none of what's inside here give us a first term of 1/4. Therefore, I'm going to go with E, none of these. Let me check the answer on 15. Ah! God, I got one wrong. D. How is that the case? How is that equal to D? When I is 1, you have 2 minus 1 over 16, which is 1 over 16 squared. And we got 1/4 squared. Did we not? We took f of 1/4, plugging in 1/4, we get 1/4 squared plus 1. We get that as our first term. Notice that C would work if this was a plus 1. If that was 2I plus 1, the first, no it wouldn't. The first term would be 3/8. If it was just 2I over 8, now that works. 2I over 8. Notice that 2I over 8 squared plus 1 gives you this term when I is 1. It gives you this term when I is 2. It gives you this term when I is 3. So 2I over 8 squared plus 1 is what we want for an answer. We need a 2 in front of that I right there, and it would work.
Yeah.
I don't see where C works myself. Or D. They said D was correct. I don't think it is. I think they've made a mistake, but might be something worth talking to your teacher about.
Okay.
And I'm sorry, we are out of time. I knew there was no way we were going to get through 20 questions in an hour. And I realized the hardest two are 19 and 20 because, first of all, they're not multiple choice.
I think I can be able to figure them out, though.
You can certainly do A easily using the trapezoidal rule. We went through a complete trapezoidal rule. And you would go from 0 to 1. In other words, they want f of 1, so you're going to, f of 1 is going to be the integral from 0 to 1 of sine of t squared dt. That is not an easy integral to integrate. There's no way to do it. That's why they're having you approximate it with the trapezoidal rule. And as far as what intervals f is increasing, you can graph that and look at it.
Yeah.
And the average rate of change, that's 2k is the answer for C.
Yeah.
That integral is equal to 2k. 20 I didn't look at yet. But it's pretty similar to others we've done. But
yeah, I should be able to figure it out.
It's definitely tough. All right. That was exhausting.
Okay.
That's definitely some harder calculus. So we'll leave it at that, and I will talk to you next Saturday.
Thank you. Talk to you next week.
All right, Chase. Bye-bye.